Okay, so our next example in this series is going to look at the boiling points of substances, and we are asked to compare two pairs of substances and look at which ones will have the higher boiling points, or discuss which ones will have the higher boiling points. So in our first case, we have halides, so bromine or ICl. Right. Bromine is, of course, a non-polar molecule, and ICl is, of course, polar because chlorine is more electronegative. So because this one is polar, we expect it to have the higher boiling point. Why? Okay, so that might seem like a misconception or easy misconception. It's polar, so non-polar here means it only has London dispersion forces. Polar means it has London dispersion forces plus dipole forces, which leads to the higher boiling point. Okay. So as always, if you need to judge whether or not something has a higher boiling point, etc., you look at its intermolecular forces. Okay. B, we're looking at neon versus krypton. Krypton, right? Yeah, krypton. So krypton, both are noble gases. Neon is higher on the periodic table, and krypton has the higher molecular mass. There's a higher molecular mass, and that is why it will have the higher boiling point. Because if a substance has a higher molecular mass, it has a higher boiling point. So those are two things. More or stronger intermolecular forces means higher boiling point. Higher molecular mass means higher boiling point. Comparing things of the same intermolecular forces, you look at molecular mass. Comparing things of different strength of intermolecular forces, you look at the stronger intermolecular forces. Okay, that was just a short example to remind or refresh that idea. Okay, thank you for watching.